everybody. So I hope you all are staying safe and being smart in this trying times. So as we know, during this pandemic, there's a lot of misinformation that's being spread by our media and especially from our politicians, and there's a lot of just like false information being spread by the people who are listening to them and not checking their information, or who are making unsafe decisions based on the information being spread, such as these issues.
The nasal passages and the nasal membranes are the coolest part of the body. That's why the virus tends to go there until it then becomes healthy enough to go into the lungs. This sounds really goofy, and it did to me too, but it works. Once the temperature reaches 136 degrees Fahrenheit, the virus falls apart and just it disintegrates, okay? And I said, well, how would you get the temperature up to 132 degrees? The answer was you use a blow dryer, because it's capable of doing that. So you hold a blow dryer in front of your face and you inhale with your nose, and it kills all the viruses in your nose.
Are you taking this vote too seriously wearing a mask right now?
Look, members of Congress are human petri dishes. We fly through the dirtiest airports, we touch everyone we meet. So if anyone's going to get coronavirus, it's probably going to be Congress.
Think about how the world would be if you tried to quarantine everybody because of the generic type flu. Now, I'm not saying this is the generic type flu, but maybe we'd be just better off if we gave it to everybody, and then in a month it would be over, because the mortality rate of this probably isn't going to be any different if we did it that way.
This is what happened.
Hey, so while editing this video, I realized that I forgot to mention that the clips I'm getting are from a couple of videos that Dr. Mike did. One of them was back from March, and the other one, actually I think they're both from March, they're just like a few days apart. So I will link those below if you want to go watch them, but they are from March. They are a little outdated, but he does have some other videos that are more recent, so I'll link those down below if you want to go watch them or go watch any of his other videos. So here's what you can do to try to use science to your advantage to avoid some of the misinformation that's out there. I'm going to focus on health-related issues and the sources that a lot of people use to learn about those issues. So the first thing you need to look at is, are you using a reliable source or not? With health issues, the CDC, WHO, and your local health department's websites are going to be the most reliable you can use. Aside from these, you need to look at what sources or where the information that your sources are getting their information from. So how are they using that information? Are they getting it from the CDC, the WHO? Are they getting it from some guy that they heard talking on the news? Are they getting it from conspiracy theorists? All that is really important to telling the reliability of a source. Alright, so next up we've got observations, and in science, observations are used to observe things that are happening in nature, things that we might want to explain, and it's often seen as a very good starting point for scientific research and coming up with a hypothesis. So whenever you're using observation to determine whether you're looking at false information or not, you need to question where your source is getting their information from. Like, who are they referencing? Are they referencing people such as the CDC and the WHO, or are they referencing kind of conspiracy theorists and people that, or are they, and like, what's the reliability of their references? Another thing you can look at is, how are they speaking of the references and people that they're sourcing? Are they discussing or referencing their sources in a reliable way that shows that they respect the information they're using? Or are they speaking condescendingly and with this kind of, I am better than you, you don't know anything kind of way? Okay, so next we have explanation, and in science, explanations are used to describe or state the reason that something is the way it is. Another good word for this is hypothesis. So I'm sure you're asking, how can this be used to assess the dependability of my source? And honestly, this is going to be a lot more of how you can observe your source in questions, their own explanation. So first thing what you're gonna want to ask is, does the explanation in question make sense, or are you already questioning it? Another thing is, have you heard this explanation or something similar to this explanation said before, either by a trustworthy source or by someone you know, having heard it somewhere? Another, or how you can judge the strength of your source's claims is going to be, does it make sense with what you know of how the world works or what science knows of how the world works? Um, you also need to be able to explain why you trust this source. Like, are you willing to explain to your teacher or to your friends why this is a trustworthy source? If you can't explain to somebody why you trust this source, maybe you should find a different source. Okay, so the next thing is going to be experimentation. And in science, we use experiments to test our hypothesis of a given issue and try to determine the legitimacy or of our hypothesis, or whether it needs to be re-thought out or re-looked at. So obviously, when it comes to epidemiological issues, you cannot go out and do your own experiments. That's just not possible. So, but here's what you can do to kind of look at the how a source is getting their information. So you want to start with, is the experiments that your source referring to, are they respectable experiments? If your source is doing their own research, have they discussed the possibility of false confirmation or false rejection? Are there Did they look at causally linked other issues that could interfere with their experiments? Okay, so real quick, we're going to talk about false confirmation and false rejection. So false confirmation is when a scientist is able to confirm a claim or hypothesis to be true, which is actually false. So a good example of this would be any ghost hunting shows which claim to catch evidence of a ghost. So where we are at in science today, we cannot prove that ghosts exist, and a lot of ghost hunting shows claim to have evidence of ghosts and claim to have proven that they exist, but where science is today, we know these claims to be false. Okay, so false rejection, on the other hand, is going to be whenever a scientist rejects his claim or hypothesis when in actuality that claim is true and should have been confirmed. An example of this would be your dog being super itchy and you being like, oh, he must have fleas. But then you go to check him for fleas and you don't see any fleas. All you see is like maybe a little bit of dry skin, but there's no like flea dirt or fleas. And so you reject your hypothesis that your dog has fleas, when in actuality he does have fleas. You just happen to miss the signs, or you looked in an area where there were no fleas. Okay, so you'll remember that I mentioned causally linked issues in experiments. So within that, we have the need to rule out chance, which is an important part of any reliable experiment. And then when the scientists are presenting their data, they will mention a margin of error when necessary, as with ruling out chance. And if they don't, their reliability needs to be called into question, because scientists who are confident in their work, or who want to be taken seriously, are going to mention their the uncertainty and possible uncertainty of their experiments. So within epidemiological issues, we also have, or a lot of epidemiological issues are going to be studied in retrospective studies. This has to happen because of morals, and it is morally wrong and not legal to introduce a disease or harmful body to a healthy person. So within retrospective studies, we have a control group which does not have in the disease or whatever in question, and then we have our experimental group which does have the disease in question. So within that, the scientists are going to then just most likely observe what's happening. They might go back and look at what happened prior to the experimentation that either overlaps between the two groups or only one group has to help answer whatever question the scientists are asking. Um, this can also be helped this could be helped with the COVID-19 study. This is likely the type of studies that would have been held when they were trying to determine how COVID-19 is spread. And a lot of retrospective studies are going to be, it's going to be really hard. It's hard to rule out chance in retrospective studies. So that is always an issue, but it's not always an issue that can be fixed. So that needs to be kept in mind as well. But retrospective studies are most likely the studies you will find when looking at health-related issues. Okay, so I hope y'all enjoyed that, and I hope that you learned some helpful information that can help you to avoid the false information being spread out there. So I hope you all stay safe and make smart decisions. Bye.